Hi grade 11s, and you are back, and Yuvala's with us today and he's taking grade 11 maths.
And we've then got this new really great tool called the quadratic formula, which I hope you've seen at school, but I'm going to introduce you to it as well. Okay, and I think that's a really good place to start. Remember the quadratic equation, we spend a lot of time talking about this in grade 11, even in grade 10, also in matric. We learn about parabolas, which are actually drawing a quadratic equation, and we learn how to solve quadratic equations. Okay, so the quadratic equation in general, let's see if we can try that again. Y equals ax squared plus bx plus c. Now when I say solve a quadratic equation, what will normally happen is you'll be told that this thing equals 0. Okay? And what that means is you are now solving for x. Solving for x. Okay? So for example, I might tell you that y, or let's really get fancy here and say f of x, which is the name of the function f, it's equal to y, which is, let's make up numbers. So 1x squared minus 3x plus 4. Okay? The minute I say solve, okay, for f of x equal to 0, what it actually means is I'm looking for those values of x that I can substitute into this quadratic equation, which will satisfy this equation. In other words, when I plug in that very specific, very unique x value, these three numbers together, when I simplify it, are going to end up with a 0. Okay? And I've shown you how we complete the square in order to find out this x. And we now have this really great thing called the quadratic formula. Okay? If you're really interested in it, you can read up about the derivation of the quadratic formula. For now, and for the kind of confines of our grade 11 syllabus, you need to take my word for it. Okay? But the solution, okay, it goes in any quadratic equation where we have y equals ax squared plus bx plus c. Okay? If I set this thing equal to 0, so in other words, I only look then at this part here. For those three numbers, any number a, any number b, any number c, we have this great thing called the quadratic formula. Let's write it down. It is in the formula sheet of your final matric paper. Grade 11s, I think you need to be smart and learn this off by heart. And basically it goes x equals negative b plus minus b squared minus 4ac, and that is all under a square root sign, and that is all over 2a. Now initially when you look at this thing, it kind of looks complicated, hey? It has this plus or minus over here. It's got surds. I know you guys generally don't like surds, but really this is calculator work, okay? I need you to see this and go, great, this is easy, okay? For those of you that have struggled to factorize a trinomial in grade 10, well, you're really going to love this formula, because this formula means you don't have to think about factorizing trinomials anymore, because this will work for any trinomial, okay? Let's do an example and I'll come back to that point about factorizing and we'll put it all together. Let's do an example. So say I have solve, okay, for x. Remember we are working with equations, solutions for x. And say I give you the equation 3x squared minus x equals 5. Okay? So what I'll notice is that this particular expression has all the makings of a quadratic. What I can do first is I can bring this guy over to the left-hand side, and what I'll end up with, let's extend this page, is I'll have 3x squared minus x minus 5 equals to 0. And this really, really looks like one of our standard form trinomials. Okay? I hope you can all see, what do I have here? I've got a equals 3. That's this number here. I've got b equals minus 1. That's the number in front of the x. Let's see if we can neaten that up a little bit. B is equal to minus 1. So there's an invisible 1 in there. And of course my c value is equal to minus 5. Okay, you should all be able to do that. I'm talking coefficients. Those numbers that sit next to those x or x squared values. The c term is the constant term. The term that does not have an x. Okay? What do I do now? It's really just a case of substituting into a formula. So I go x equals negative b plus minus b squared minus 4ac, our magic formula. Put that in the square root sign, and I have all of that over 2a. Now, I'm going to show you how to substitute, and it's really, really easy. Negative b. So I go negative, bracket, negative 1, plus, minus. Third, b squared is negative 1 squared. Now, this is an area where sometimes students make mistakes. Because my b term in this example happens to be a negative, you actually need to put this b squared in brackets. So what I often tell my students is to think of these b's and these a's and these c's as placeholders. In other words, put the place in first. So I've got a b squared, there's a placeholder, minus 4ac, all over 2a, all over 2a, 2a, another placeholder. Now, let's populate those placeholders. In here, I have a negative 1, minus 4ac, a is 3, and c value we said was minus 5. Let's see if we can neaten that up. I'm just running a little bit out of space. I have a minus 5 here. Okay. And then I have 2a, which is 2 times 3. Now, if you really want to, you can go and work this out. Okay, unfortunately, I don't have a calculator with me today, so I'm going to leave this question there. What I am challenging the callers with is I want you guys to take your calculator, and if you have a visual calculator on 2 lines, you can literally plug this in as you see it. Okay? And after the ad break, we'll see if we can confirm your answer. Okay? So you literally plug it in as you see it. Now, remember, because a quadratic, okay, it's got an x squared, we are expecting 2 solutions to this quadratic. Okay? It's to the power of 2 solutions. Now, that is the secret of why we have this plus or minus. So pretty much, we use the minus sign to get one solution, and then we use the plus sign to get another solution. So it's 2 solutions. So when you are plugging this in on your calculator, you will first use the plus, and then use the minus, or vice versa. It doesn't really matter. I think you get the idea. Okay? 2 solutions. So you literally plug it in just like that, using a plus and using a minus. Okay? So there's a challenge to all the callers. I challenge you guys to plug this into your calculators and SMS, tweet, phone in your answers, shout them out to the room, okay? And we'll confirm if your answers are right. Okay, so having said that, I think that what we'll do is we'll go on to a slightly more challenging question, because we have now covered all those techniques that we use to solve quadratic equations. I did completing the square with you last week, okay? Factorization is something that you've done already in grade 10. In other words, if, for example, you have x squared plus 2x, let's make it a minus 3 here, equals to 0. You could say x minus 3. I'm just making this up, but I think it will work. Or rather, x plus 3 and x minus 1. And because we know how to factorize, that is an expression that factorizes. We can say, well, x equals minus 3 from the first bracket, and x equals 1 from the second bracket. If you wanted to, and your factorization wasn't so hot, you could then go and plug your a value here, which was a is equal to 1, b is equal to 2, and c is equal to minus 3. Don't forget your signs. C is minus 3. You'll get the wrong answer. Okay? And you could then go and plug those into the quadratic formula. And if you've used your calculator correctly, and you've plugged things into the formula correctly, you will end up with an answer of x equals minus 3 when you use either the plus or the minus, and your second solution will be x equals 1. Okay, so that's just kind of putting it all together. So factorization, completing the square, which we're going to talk about, although I did spend an hour talking about that last week. And remember, we don't like to complete the square unless we are told to complete the square in the question. So my suggestion, unless you're really hot at completing the square, you don't have to do it unless the question specifically says, please answer this question by completing the square. Okay, so I've got a little bit more time, so I'm going to show you an exam question that really tests this theory. So the exam question that I've chosen, and by the way, I've chosen it out of our textbook, okay? On page 59, you start with some of the quadratic things, and you will find a whole really good mixed exercise on this stuff, and I've literally chosen a question out of there. And if you go y squared plus 3, okay, plus 12 over y squared plus 3 equals to 7. And the instruction is solve for x. So very important. It's or rather solve for y. We're working in y here. Let's erase that and put in a y before you guys all phone in from the whole country to tell me that I'm confused. Solve for y. Okay? So what we can do here is we notice that we've got something that's shared. Okay? For those of you guys that are really good at LCDs, you'll notice that the LCD is y squared plus 3. Now, I've just gone and put brackets in. The brackets weren't there before. But I'm putting in the brackets because what I notice is that I have, let's rather put these brackets in color, there and there. I'm going to put a bracket there as well. I have commonality. In other words, I have a bracket that looks the same now. And if I had to multiply through by this LCD, I would have to multiply each term that doesn't have that LCD by this y squared plus 3. And I would end up with a y squared times y squared, and a y squared times a y squared is a y to the 4. Okay? And that is a hint that that is not the right way to do this question. The minute you end up in grade 11 with y squared, y cubed, y to the 4, y to the 5, y to the 6, even matrix, something in your mind needs to go bing, bing, bing. This is a K method question. So the trick that we use is we go let, I hope you can see this, pink, y squared plus 3 equal to k. In other words, wherever we see a y squared plus 3, and I'm going to put it in brackets, brackets are great because brackets make your work visual. They prevent you from doing stupid things like not distributing minuses or putting times where it should be a plus or a minus. It's really good to put those brackets in, okay? And what I end up with in this question is a k over there. And I'll put that k like that. And then I've got plus 12. And then underneath that I've got another k. I'm going to keep my pink going here. Okay? And then I've got equals 7. Equals 7. Equals to 7. And the next thing I do, because my work is now visual and I see that I've got LCDs in this question, I'm going to find an LCD. So here we go. LCD is k. I multiply through by that k, and I end up with k squared. Plus 12, let's try that again, equals 7k. Remember, the LCD you've got to multiply through to both sides of the equation, including the right-hand side here. And this is now starting to look like a trinomial. I've got k squareds, I've got k's, and I've got just a single number. Let's bring everything over to one side. Okay? So, I've got k squared, I've got minus 7k, I've got plus 12, and I've got equals to 0. Now, if you guys want to, and you can't see that this thing really factorizes quite nicely, why? Because factors of 12, that'll give you 7, are 4 and 3. So this one does factorize, okay? But if your factorization a little bit shaky or you really want to be sure, go ahead, plug this into the quadratic formula. Use a is equal to 1, use b is equal to minus 7, and your c value is of course going to be 12, okay? You will get the right answer. You'll then use a plus, you'll use a minus, you'll get the right answer. I'm going to do this the factorization way. Factors of 12, of course, are k minus 4 and k minus 3. Because minus 4 times minus 3 is positive 12, and minus 4 minus 3 is minus 7. And I've got now a solution for k. I've got k is equal to 4. Okay, let's space this out a bit better on the board. You'll see why in a minute. I've got k is equal to 4. K is equal to 4. And I've got k is equal to 3. Okay, you should all be with me up until that point. But this question did not ask me to solve for k. I just used k because that's the trick. Okay, it's one of my tools that I can use to answer questions like this. I now need to finish this question and solve for x, or y in this case. What was my k? I wrote it down, and you should always write it down for your examiner. I said k is y squared plus 3. So now I substitute back. So I end up with y squared plus 3 equals 4. Okay, I could have also left the 4 on that side. Or I've got y squared plus 3 is equal to 3. Okay, so I hope you can all see now we're very close to a final answer. Y squared is equal to 1. What do I do when I have a square on one side? I square root both sides. What do I need to remember whenever I square root both sides? To always include a plus and minus. We did speak about that last week. So in other words, let's put that in color. I'm going to square root the left, I'm going to square root the right, and I have to put a plus or minus. If you don't, well, you're going to lose your marks. So we have y is equal to plus or minus 1. Okay, because the square root of 1 is 1. Over here, have a look. Your 3's cancel out. I'm left with y squared equals 0, which means, of course, that y equals 0. Okay, so there you have it. There is an exam question. I hope maybe you're wondering how this stuff really gets examined. Okay, matrics, when you start doing lots of past papers, and you should already be kind of getting your head around exam technique, what you'll find normally is that in the first question or the second question of your paper 1, okay, there is a question which looks something like this. It may have a surd, it may have a completing the square, it will look something along these lines. You need to expect it, so that's exam technique. Expect certain questions to come up. Why? Because they come up in every exam paper. Because we want to know as examiners that you are able to complete the square or solve the quadratic equation. And remember, we had this question where we first learnt about this quadratic formula, and I'm going to show you now how we plug this into our calculators, and I'm kind of hoping that most of you got this right. Okay? First thing I do is I use one of those, a fraction button. I've then got a negative bracket, okay, negative 1, close bracket. I'm going to use the plus first, plus. I then put in my surd, okay, so you see it's really easy. It looks complicated, this formula doesn't look lacquer, but in actual fact it's really just a case of substituting in on your calculators, okay. I've then got a negative 1 squared, so I'm going to put that in as I see it, negative 1 all squared. I've even got a squared button there. Okay, I've just got one bracket too many. Let's get rid of that. All squared. Okay, negative 1 squared. Minus b squared minus 4. There's a 4 there. And then I've got my a value, which we said was 3. And then I've got my, for a c. What was the c value? It was negative 5. Negative 5. Close bracket. And all of that, I then push this button to the right. And that will then take me to the bottom. Okay, let's see if we can get there. I want to get to the bottom. Hang on. Bottom. Okay, bear with me. Let's see if we can try that again. I'm using a very big calculator here. There you go. On the bottom, I've got 2 times a, which is 2 times 3. I've used the plus. So the answer that we get there is 1 plus root 61 over 6. Okay, so if you got that answer, give yourself a pat on the back. Okay, and give yourself an A. If the question said solve to 1 decimal place or 2 decimal places, that is, by the way, a hint. They are telling you to use the quadratic formula. Why? Because there is no one on earth that is going to work out one of these in their heads and work it out 2 or 3 decimal places. They are definitely going to be using the quadratic formula. Okay, so I use this SD button, 1.4683, etc. Now, to use the negative, I simply go back to the question, okay, and I simply go back to that point where the negative was. So I don't have to retype it. I can just erase my, where is my delete? Erase my plus, put in a minus, press equals, and I get 1 minus root 61 over 6. So again, you should have gotten those 2 answers in decimals, negative 1.135. Okay, the quadratic formula is easy. It shouldn't take you more than a minute to use. And gone are the days of looking at something, a quadratic at least, and not being able to factorize it and therefore not being able to do the question. You're allowed now to use this always unless the question specifically says do not use it. Okay. So, I don't know if anybody has...
Let me have a look. There are one or two that have gotten it right, but I just want to see here. Ntando wants to know, do we really have to use a calculator to answer this equation?
Well, Tando, what happens if I say to you, please give me the answer correct to one decimal place? So if you were really good at arithmetic, okay, it would be quite easy to work through this here. So minus minus 1 is plus 1. Okay? Let's use the minus minus. 61. How do we get 61? We go minus 1 squared is 1. A minus times a minus is a plus, so it's 1 plus. 4 times 3 is 12, and 12 times 5 is 60. And then you end up with 61. On the bottom you have a 6, 2 times 3. But, do you know what the square root of 61 is? Because I sure as hell don't. It's an irrational number, okay? So if you've been watching the grade 10 work, an irrational number. Those numbers where you have a surd and it doesn't work out nicely. In other words, the decimals continue forever with no particular order whatsoever, okay? And irrational numbers, not so easy to work out without a calculator. So really, if I said to you, show that this answer is 1 minus 60 plus or minus 61 over 6, you don't need a calculator for that. If I said to you, please give me the answer to 1 or 2 decimal places, well then definitely you would need a calculator for that question.
Okay, fantastic. And this gets to, Polaki, I see, yes, you did get the correct answer. They're all shouting at me, they're saying, why aren't you saying my name? Yes, you did. Fantastic. I want to know, it's got to do with rounding off to the nearest decimal. Just let me get to the question. It'll take me 2 seconds. Takalani said that he's struggling when it comes to an answer like 1.478632 ... How do you write it to 2 decimal places?
Okay, so Takalani, I don't want to spend too long on this because I've got some other exciting quadratics to get through, but I think it's worth spending just a minute talking about rounding off, okay? So if I then have, for example, negative 1,135, if I told you that I'm rounding this thing off to 2 decimal digits, I need to look at the second decimal place here, and that's 3. I then look at the third decimal place. If the third decimal place number is 5 or greater, I round up. So this 3 would now become a 4, and I would stop there. I would say negative 1,14, that would be the end of it. Okay. If I was rounding off to 3 decimal places, I would look at the fourth decimal place, which is a 0. 0 is less than 5. That means that my third decimal place remains unchanged.
And here's another one. Reflow wants to know, do we write answers in 2 decimal places? So when you get an answer like you've gotten, is it...
Yes, that's a good question.
Yeah.
Reflow.
I think so. I think so. I think it's one of those names, you know.
Okay, that's a really a good question. Okay, because I know that most of you in grade 11 you're not used to looking at answers that look like this. Okay, but think about it for a minute. What is more accurate? That 1 minus root 61 over 6, or that? Okay, negative 1,135. Which one's more accurate? Obviously, this one's more accurate because we're not rounding off. And there's no way that you can sit and write all those decimal places forever. At some point, you will have to round off. So in maths, generally when we write rational numbers, and there are millions and billions of irrational numbers, excuse me, we just leave them with a root. Okay? So if your answer is root 6, leave your answer as root 6, unless the question says round off. From now on, and for the rest of your matric life, you do not convert to decimals unless the question says convert to decimals. Root 6 is a number, just like 5 and just like 3.
Cool.
Okay.
Fantastic.
It's a good question. I get asked that a lot.
Fantastic. Okay, last question, Yuval, and then I'm going to let you carry on with your question, I swear, and it should be a quick one. Lou wants to know, how many marks do we get for using the quadratic formula?
Okay, so really it depends on, first of all, what grade you're in. In matric, normally we give sort of 3 marks for a final and complete answer. Okay, and that means you've used the quadratic formula and you've also given the rounded off or the surd form versions. Okay, it's an easy mark scorer on your exam. When you see that question, you need to go, this is cool because I've got 3 really easy marks or 2 really easy marks. But somewhere between 2 and 3 marks, I would say. It may be in another question, like this question I did previously, okay, where we had to convert to k and then we had to eventually get our answers, and maybe at the end you'll need to use your quadratic formula. So there might be more to it, okay, but that's not the case in a shorter question, 2 or 3 marks.
We'll see you soon. Bye, guys.